Good evening, everyone. It's great to see you all again. As you know, I'm Garante Choco, and I'm one of the co-founder of Our Future is Science, along with my dear colleague, Aaron Mertz. Along with the Our Future is Science team, we are delighted to welcome you to our Community Talk series. This series is part of the mentorship and scholars programs of Our Future is Science. Our Future is Science is a joint initiative between the Aspen Institute Science and Society Program and Coda Societies. We're committed to sparking youth curiosity about, passion for, and confidence in STEM to not only advance science and ensure that diverse voices are heard and valued, but also to solve society's most pressing issues. We're generously supported by Genentech, the Manitou Fund, the Rita Allen Foundation, 3M, and Lida Hill Philanthropies. And again, I'm going to repeat that if you want to turn on your cameras, we'd really welcome that. There's always been an intersection between big data and technology, with one feeding into the other, all impacting how we live, work, and play, and engage with one another. Understanding their connections with social justice is a key component of the Our Future is Science program, and we're happy to kick off the learning in this area with tonight's talks, which center on the collaborative efforts of Dr. Pierre Gentine, who's a fellow Frenchman, and Dr. Courtney Cogburn of Columbia University in New York City, about the intersection of climate science, data science, and artificial intelligence. After their talks, a few of our wonderful mentors who focus on data science and technology will say a few words about their work. And then, as usual, we'll follow up with your questions to our speakers. And so, to introduce our speakers, I will pass it on to my dear colleague, Dr. Jelana Sheets.
Hello, everyone. I also want to extend a warm welcome for tonight. And I'm thrilled to introduce you to our speakers. Dr. Courtney Cogburn is an associate professor at the Columbia University School of Social Work and faculty of the Columbia Population Research Center and Data Science Institute, where she co-chairs the Computational Social Science Working Group. She employs a transdisciplinary approach to improve the characterization and measurement of racism and in examining the role of racism in the production of racial inequities in health. Dr. Cogburn's work also explores media as a social stressor that contributes to racial inequities in health. She also works at the intersection of emerging technology and social justice and is the lead creator of 1000 Cut Journey, which you all are familiar with from your exercise this week. And so 1000 Cut Journey actually premiered at the 2018 Tribeca Film Festival. And Dr. Cogburn is also the co-founder of the Justice, Equity, and Technology Studio at Columbia. She is a member of the American Medical Association's External Equity and Innovation Advisory Group, the Robert Wood Johnson Foundation Health Equity Collective, and also serves as the Chief Equity Officer at Knowledge Transfer Director of the Learning the Earth with Artificial Intelligence and Physics, LEAP, which we'll learn about today. And Dr. Cogburn completed postdoctoral training at Harvard University and the Robert Wood Johnson Foundation Health and Society Scholar Program and at the Institute for Social Research at the University of Michigan. She received her PhD in Education and Psychology and an MSW from the University of Michigan and completed her BA in Psychology from the University of Virginia. So I'll introduce our next speaker, but welcome Dr. Cogburn. And so we also have Dr. Pierre Gentine. He is an associate professor in the Department of Earth and Environmental Engineering in the School of Engineering and Applied Science. He is an investigator in the Columbia Water Center and director of the graduate program in Earth and Environmental Engineering. Dr. Gentine investigates the continental hydraulic cycle through land-atmosphere interaction, boundary layer turbulence, convection, ecohydrology, and remote sensing. He received his undergraduate degree from Sapero in France. He earned his PhD in civil and environmental engineering at MIT in 2010 and joined the faculty at Columbia University in 2010 as an instructor in applied mathematics and then as a tenure track professor in earth and environmental engineering in 2011. So you can see just from these introductions that it will be an informative and interesting talk, just bringing their expertise, their respective expertise together on this project titled LEAP.
And so Courtney, without further ado.
Yes. Hello, everyone. We're so delighted to be with you this evening. We've been learning about the work happening through your program. It sounds really amazing, and hoping to find other ways to stay connected and involved with all the amazing things that you all are doing. So we wanted to do a little bit of a personal introduction as well. So I was born and raised in Oklahoma. I come from a family of educators, farmers, laborers, Black cowboys. And in addition to all of that, I'm also a second generation PhD. I'm also the mom to Idara, who's on the lower side of this slide, eating a donut. And I'm a professor at Columbia. And Jelana, thank you for the warm introduction and overviewing what I do. But the summary of what I do is I think about what racism is, how we measure it, and what we do about it. And I take lots of different approaches for addressing that, which is part of my role with the LEAP Center. And I'll hand it over to Pierre.
Thanks, Courtney, and thanks everyone for the opportunity. So it's really a pleasure to be here today. And I mean, the intent is also to make that really interactive. So feel free to just stop us, anytime if you had any questions. So quick background about myself. So I was born in France, as Garance was actually saying. So also a fellow French citizen here. And I got my bachelor in engineering. So very typical if you're interested in science back there. And then at some point, I wanted to kind of start working on some things like related to theoretical physics, but I wanted to have more of a human perspective, and that led me to start working on environmental type of problems. And that's when I moved to MIT to do a master's and a PhD there, looking at environmental problems. And kind of the core of my work now is really on climate change and how that's been impacting our life. Next, yeah. And I've been living in some pretty nice cities. I've been lucky. So I've been in Paris, Marrakesh, back down there. So a lot of cities you would want to visit, and including Strasbourg, my hometown, which is really pretty if you have time to visit. And for the center, I'm basically the center director, and I'm also in charge of the diversity there. So what we wanted to talk about today, and again, there's no bad questions, or feel free to interrupt anytime, raise your hand, or just talk, that's going to be relatively informal, is to really give a little bit of a background as to what the problem is, right? So what is climate change, And oftentimes I feel personally that we have, and especially the politicians, have a bad perspective on what climate change is, and so if you want to act, it's actually good to actually know what we are talking about, right? So what is kind of the topic we have. So very quickly, we wanted to kind of introduce you, and maybe that's, that already, especially being in STEM, but what is the greenhouse gas effect? So basically, how is the planet actually warming, just to have a little bit of a baseline and common language and understanding. Once we know that, we can talk about the impact of our emissions, so why humans are actually playing a big role in the Earth, right? And why are we talking about the Anthropocene now? The fact that humans are really changing the environment and the Earth, right? So why is that? And then we can talk about what we call climate mitigation and climate adaptation. And we'll see that they are two different concepts. Sometimes people use them interchangeably, but they are very different. And so basically, what can we do about climate, and how can we act? And, if I were a student right now, we just work on those things. I think it's the best topic, because that can, that can change the life of generations to come. So I think it's a great topic to work on, and it could have a huge impact, so I hope you can be motivated to join us. And then very importantly, we'll talk about how that impacts inequity and injustice. So you will see how it percolates. And the more I've been into that, and it's also like a lot of like where I'm coming from is inequity has always been an important topic to me, racial justice as well. But now when you think about climate change, really it percolates into all of those spheres, you know, and you will see that it's very difficult to take that and move it away from those different pieces. You know, justice, equity, and racial justice are really important pieces of that, you know, because it's a global and problem affecting really everyone. Okay, so first step is, what is the greenhouse gas effect? So as my son would put it, and he's 11-year-old, it's actually a good thing, right? So without the greenhouse gases, it would be a very cold planet. You know, you can think about Mars, you know, or planets where there's very little atmosphere. They tend to be very cold or very warm, right? So when we have the sun and sunlight, it can be very warm. And without the atmosphere, it would be very cold, you know. So the reason for that is that the atmosphere actually traps some of the energy. And basically, you can think of that, it's like a bubble and traps some of the energy, and it radiates back to the earth, right? So basically it's warming up. It's like a pot, if you will. And that's a good thing for us, you know, to some extent, right? So if we have some atmosphere, if we have some greenhouse gases in the atmosphere, that's a good thing because it traps some of this energy from space, remits it back to the earth and warms up the surface. Now, the issue is too much of that is not good, right? Because that's going to trap more and more of the energy, and therefore that's going to warm more and more of the planet. And that's basically what we call global warming, right? So as people emit, they will add greenhouse gases into the atmosphere. And basically we are trapping more and more of the radiation, and therefore we are warming up the surface, which is not good in that case. Next. And who is actually generating that? Is mostly humans. So here is basically the greenhouse gas emissions. So, and where they are coming from. So it's mostly human anthropogenic emissions. You can see a lot of that is coming from the energy sector. So transportation, electricity and heat. We oftentimes forget about that, but when you're heating up your building in the winter, you're emitting, right? When you're cooling off you have your AC, you're also emitting a lot of greenhouse gases. And that's actually the largest share. We typically always think about cars, but that's actually second, you know, so that's actually important. And of course, we have the industries, I mean, you would expect given the smokes. And you also have things that are maybe less directly linked to us or more less tangible, right? Agriculture, right? Land use change, you know, when deforestation, for instance, we talk a lot about the Amazon when we are deforesting, and that has a big impact, right? Because you're taking some biomass and, you know, you're burning that, you know, and so you might be actually putting that, or it will take a long time to decompose and will actually make its way into the atmosphere. Okay, so at the end of the day, what will happen is the emissions, especially from the energy sector, the land use and the agriculture, are going to basically add some greenhouse gases into the atmosphere. We call that the emissions, especially of carbon dioxide. So you can see on the right-hand side, that's the largest share, like 3/4 roughly. We also have methane. So you might have heard about that very recently, especially with the COP agreement. People talk a lot about methane. It's a very potent greenhouse gas. It's very important as well. Typically, you can see that, especially now from satellite data, which is really cool. So that's actually very new. We can use machine learning and satellite data to look at plumes from methane. You know, you can see people that are emitting and that are saying that they are not emitting, you know, so you can actually track that from space, which is pretty cool. And nitrous oxide, so that's mostly from agriculture. Basically, you can think of that like fertilizers, right, which are also emitting. And those gases are basically warming up the planet. So what's special about carbon dioxide? So here is just giving you an example between two gases, so methane, CH4, and carbon dioxide, so CO2. And the big difference is people say methane is actually very important, which is true, right? So methane is actually more important for the same amount than carbon dioxide. It has what we call a very strong radiative effect, so it warms up the planet a lot. But an advantage of methane is it naturally decays. So if you were to release some methane, after a few years, so roughly 8 years to 9 years, it will actually decay naturally. So you can emit, but after a few years, it will actually decay. Now, if we take an example, so let's take the example of transportation, right? So as we said, transportation is going to release some CO2, and you could have some other gases. So if we were to continue emitting and we were to keep increasing the emission, which is something we've been doing forever, right? So in the US, in China, we keep increasing the emissions from year to year. And we feel happy because the rate of increase is decreasing, but still we are increasing, right? And if we were to increase, what would happen is basically what you have on the red column on the left-hand side here. It will basically generate more and more warming, right? Because we keep adding those greenhouse gases and CO2 in the atmosphere, and that's basically warming up the planet, right? Now you could have a scenario which would be a good scenario, like a more positive outcome where people will be flat, right? So we won't be doing more, but we will be kind of doing the same, and maybe the population will increase, and maybe we will have more cars, but those cars are more efficient, right? So we remain relatively flat, which is what you have in the green area, or orange maybe, sorry, I'm colorblind. So kind of we remain flat, but if you think about carbon dioxide, you will keep adding that. You can think of that as a bathtub. You keep adding water into the bathtub. So the level of the bathtub will keep increasing, right? So what it means is that it's a greenhouse gas, right? So that's going to still be increasing and warming the planet, which is what you can see at the bottom, right? So even if we were to remain flat, we still keep on increasing the warming, which is a bad thing, right? What we hope, and we are quite far from that yet, at least globally, is to have falling emissions, right? So we really reduce our emissions, right? So that will be the blue area, meaning we would reduce the amount of fuel we're using for transportation to a large extent, right? So we will be decreasing that. But even then, I mean, what we typically forget is that we will still be adding water in the bathtub, right? So it means that we will still keep adding basically carbon dioxide in the atmosphere, and therefore we will still be warming up the planet, right? So that's one thing that people forget. So we keep talking about reducing the emissions, but that's insufficient. Even if you were to reduce the emissions, you will still be adding carbon dioxide into the air, and therefore you will still be keep increasing the warming of the planet, which is a bad thing, right? And really what we would need is actually the right-hand side here, which is actually very, very far from where we're at right now, which will be, we need to go to negative emissions. And what do we mean by negative emissions is that, imagine there's still some fuel, so you will need to remove all of that, right? So you will need to remove the carbon dioxide from the atmosphere. And that's really basically a climate tech challenge, right? So you will need to have some engineering capacity to actually remove CO2 from the atmosphere. And that's how you will be able to actually cool off the planet. Okay. For methane, it will be different because methane, even if you were flat in emissions, because it will decay eventually, even if you were flat, I mean, that's what you're seeing at the bottom, you will actually naturally decay that. So even if we just had full emissions, we will be fine. We don't need to go to negative emissions of methane because it will naturally decay. So eventually it will go down to zero. So you're fine, right? So the main struggle that we will have is carbon dioxide and how we can actually get that from the atmosphere.
So it takes more effort to get carbon dioxide out of the atmosphere.
Exactly,
yeah.
Because we don't have that natural decay playing for us. And feel free again if there's any questions too. And or if you feel and you don't want to talk, just put that in the chat. Happy to jump in here at any point.
And also, if I may jump in for 1 second to our mentees, if there are some terms that we do not understand, feel free to share, okay? Exactly. And then, yes, Dr. Gentine and Dr. Cogburn can explain and clarify. Thank you.
So now we get into those two concepts, so climate mitigation and climate adaptation. So what do we mean by mitigation? It's really trying to prevent and reduce the change. So ideally, removing CO2, that would be the best outcome, but at least reducing the emissions, right? We want to limit the future climate change, right? As much as we can as a society. And then there's the climate adaptation side, which is kind of the other side of or the flip side of the coin, which is climate change is happening no matter what, right? So what are we doing? You know, how are we going to adapt to that? You know, so are we building new infrastructures? You know, are we building some new systems because there's going to be more heat waves or more flooding events or droughts, you know, for agriculture? Okay, and really, I mean, at this stage, I think a lot of the focus is on climate adaptation because we feel we are already experiencing climate change and we are not yet we cannot remove CO2 from the atmosphere, but you guys might be the game changer, right? Maybe someone in the room here might have the solution in a few years to actually potentially remove CO2 from the atmosphere and basically save all of us, right? And I'll be happy to be retired. That would be a good thing. Next. So why do we need to adapt to climate change? It's really, you know, the main point is that, as we discussed before, you know, like there's this greenhouse gas effect, you know, and therefore the temperature of the planet is actually increasing, right? So, and that's what you're seeing on the left-hand side. So that's the historical data. Global temperature has been increasing by basically more than 1.2 degrees roughly compared to pre-industrial levels. So, and that's degrees Celsius. So bear with me if you're in Fahrenheit. And that's what a lot of people actually use for global policy. So you might have heard about the Paris Agreement. That's what people talk about, right? They talk about the 1.5 degree threshold or 2 degrees Celsius threshold, right? So those are key thresholds. And we use that for a reason, because that's a way to come to the table and say, that's the benchmark, right? That's what it means, right? But this global temperature, like the average temperature, is an abstraction, right? I mean, it's something that exists, but it doesn't really, I mean, that's not what we are feeling in our everyday life. And in fact, on the right-hand side, you can see a map of what will be the change in temperature across the planet based on some model projection. And what we can see, what's really important is it's not uniform, right? It's not 1.5 or 2 degrees across. You will see a lot more of that near the poles. In Africa, for instance, you're seeing a lot more of that, in South America as well. So we are not equal, right? And we are not facing the same type of impact by climate change, right? And that's an issue, right? So you already have an example of inequality based on climate change. And you might have some islands where we're already seeing and witnessing some of the impact of sea level rise, for instance, right? So there's a lot of inequity already related to climate change. And the right-hand side is really what you need, right? You need to be a bit more granular, a bit more regional, so you can adapt, right? You need to be at a more local level. You need to know what will be the increase. And really, I mean, kind of the flip side again of the story is you can look at who is actually emitting the most, right? So if you think about the US and start thinking again about inequity, in fact, the top 10% of the US in terms of wealth, you know, in terms of emissions, is actually, so you share a much larger fractions of the emission, right? So they emit roughly 73 tons of CO2 per year per person, right? If you're in the top 10% of Americans. And the bottom 50% is like an order of magnitude smaller, right? So only emitting 9.7. So what it means is our lifestyle really has an impact. You know, if you're flying every day, every week to go, say, maybe to Florida from New York City, that has an impact, right? And a lot of our lifestyle, so again, the energy or the size of the house that we have is going to have a footprint on the earth, right? And so the lower 50% is emitting much less. Next slide. But is also bearing the largest cost, you know, in terms of the impact. So they are really the ones that are being impacted the most by climate change, you know? So there's really this discrepancy between how much they emit and how much they are being impacted. And we know for a fact that poor neighborhoods or underserved communities are really being affected the most by climate change, you know? So in terms of flooding, in terms of heat waves, a lot of those events, New Orleans was a critical example showing a lot of that, for instance. Next. seeing the slide.
This is when your memorization skill
Yeah.
comes into play.
I know the next slide, yeah.
No,
It's
take your
about the
time.
Bronx. So,
No problem.
so it's just an example to show you how, if you were to go from like this very global scale, so again, what we use for policy making, you go at a regional scale, so you can think about New York State, and now you start zooming in, and now you're seeing and witnessing the impact of inequity in terms of climate change and how it affects adaptation. If you look at the Bronx, compared to say Central Park or the Upper West Side, so like wealthy neighborhoods, during a heat wave, you can have 10 degrees Fahrenheit difference, you know, which is amazing, right? I mean, that's a huge difference, right? So we are not witnessing the same impact, right? And so it means that we also need to adapt differently. And in addition to that, in the Bronx, maybe people might not have the means to actually put the AC on every single day when there's a heat wave. In fact, there's been many studies showing that where people need to really count how many days because they cannot afford the cost, right? So we don't have the same capacity to adapt to climate change. So it really showcases and exacerbates a lot of the inequity in society. So we have a question from Pearl. About steps to ensure and encourage the availability of regional data set. I would say it's very much a grassroots type, you know, especially at the small scale, right? I mean, we don't have a lot of the capacity to measure that. In fact, you'll be surprised as to how little, how few weather station data measurement we have, even in the city of New York. We just have a few, and typically at airports, you know, which are highly biased. We don't have them across different neighborhoods. So we see that typically from satellite data because we can map like from like thermal infrared, like your thermal camera. So we can do that from space. But we don't really have like weather station across different counties, across different neighborhoods. And that's really a data gap that we need to fill. That's very important to actually witness. Same goes for air quality, you know. So there's actually some effort now going on at Columbia with the School of Public Health, like going across. Yeah.
Thank you.
Thanks.
Pierre, do you know of any sort of, community-based data collection efforts? So, equipping people in neighborhoods, in communities with maybe more portable measurement devices to help give us more accurate data? Are there efforts, and I guess maybe in the climate tech space related to that you know of?
Yeah, there's been some efforts, especially now you can get really cheap sensors so people can share that and they can share the data. I'm not aware of an organized way of collecting that. I think a lot of the issue is also like the data quality. People want to have a way to compare different, so for instance, you could have a cheap sensor and a more expensive sensor, and how do you actually do that? There's been a bit of work also to use your phone because a lot of phones actually have a temperature, a thermometer in them. The question is it in your pocket or is it somewhere else or is it inside and outside? But people are trying to use those, because then you could have a lot of sensors moving across and you would have the GPS record as well. Yeah, so that's a big effort going on and that would fill that gap,
Yeah, got it.
Thanks.
So I'm not a climate scientist, so I've been learning so much about all of this along with many of you as well. But it's clear, right, that we have some basis of understanding. We know what's happening and why. We know that we understand greenhouse gas effects. We understand the role of CO2 in the environment. And we're also very clear that not everyone in society is or will be affected equally. So part of what LEAP is trying to do is think about what do we do about the problems that we are observing related to the climate crisis. So one thing that we need, right? So moving to the question of adaptation, this is coming, it's already happening. We're seeing flooding and heat waves more and more frequently. How do we adapt to that changing circumstance as it relates to climate? One thing that we need are more reliable projections. How do we more accurately predict what's going to happen and when? So when we say climate projections, we're talking about the use of data to understand what's happening and again, try to predict when it's going to happen. So we need more accurate 10 to 40-year predictions as it relates to climate changes. And those changes and being able to make better predictions within that time frame can help inform where we make investments, where we spend time in terms of research, what we do in terms of public policy and urban planning. And it's also an important window for thinking about cultural and behavioral change. Within a generation, can we change the ways we think about our relationship to the planet in our systems that we employ to help do a better job of protecting the planet, both in terms of adaptation and hopefully in the longer term, getting us to a point where mitigation is actually possible again. So what are the current gaps? We have some serious gaps in terms of our ability to make these predictions reliably. Current climate models are too uncertain. If you look at this global air temperature graph on the upper part of the slide, what this is representing, the coloring, the shade, so you have the solid line and then you have this shaded space around that line, that gap is error. How inaccurate we are in predicting where the temperature is going to be in 2060. And the top of that shading versus the bottom of that shading are completely different policy decisions, completely different circumstances in terms of that temperature difference. So narrowing that gap, narrowing how inaccurate we are becomes really, really important. Are we predicting 2 degrees difference in temperature, or are we narrowing that down to a 0.5 degree, for instance? So climate modeling doesn't translate into actionable adaptation when there's too much error. It's difficult to say, do we build a 5-foot wall or do we build a 2-foot wall? How do we spend our time and resources? How high are waters going to rise? And again, when is that going to happen? We need more accurate projections in order to do a better job at that. Pierre talked me through the significance of clouds this afternoon. So if we have one model that's predicting lots and lots of clouds that are white and reflecting light back out into space, then we will continue to have a cooler planet. If we have a different model in this range that we could possibly have of fewer clouds that are darker, then more light is going to come through and the planet will be warmer. So that's a really different circumstance. Fewer darker clouds versus lots of white fluffy clouds are really different circumstances in terms of what the temperature of the planet is going to be. So improving this model these predictions are really important. And Pierre told me that clouds account for a great deal of this error that we observe in terms of global air temperature, being more accurate in terms of these small physical processes that relates to clouds are really important. Pierre, I heard some noise. Were you trying to chime in here?
No, I think you were perfect.
Okay, good.
It's better than what I would have said.
Well, I understand less. So how do we think about as well, we're improving these models, we're getting better data, we're doing a better job of predicting changes in the climate and when things are going to happen and to what degree. LEAP holds the position that that's not useful or meaningful if we can't translate that in a meaningful way. If everyone doesn't have access to that information and the data, the climate crisis is a global problem that we all have to try and address together. If we're not able to share that data, if we're not able to effectively communicate what it is that we're finding in this science, it won't be useful. And so a big part of what LEAP is trying to figure out is how do we ensure meaningful use and application to address the evolving needs of society, and really thinking about society in a global sense in terms of our interventions. So when we think about more reliable projections are important for everything. So our ability to plan cities and different spaces, our laws, policies, and regulation, what we do in terms of agriculture and food. Are we going to have food shortages? If so, when? When is that going to happen? Where is that going to happen? So we want to be more accurate in our predictions of that. Who's most vulnerable to these risks that we're identifying? And how do we understand and predict global conflict? Or if we can predict food shortages, we can also start to predict where global conflicts might emerge. Or if we can predict certain areas that are going to be uninhabitable because of climate changes, and large parts of a population are going to be moving, migrating, where are they going to go? Is that going to cause a strain on resources? And how can we predict and anticipate that and try and minimize conflict and inequities in terms of access to needed resources? What do we need in terms of climate technology? How do we do a better job tracking and getting data? How can we think about removing CO2 from the environment? So climate technology is an important part of this as well. And global knowledge sharing, right? How do we share what we're learning in a meaningful way? So doing a better job of predicting has implications for all of this. So LEAP is thinking about climate data science and how we leverage data and how we can process data to help us revolutionize climate projections. So leap forward, we want to make leaps forward in the reliability of data, how useful these data are, and who has access to this information through synergistic innovations in data science and in climate science. So we're essentially bridging two disciplines. We're bridging data science and climate science together to try and help us make these leaps forward. So when we're talking about increases in reliability, we're talking about data-driven climate projections, more accurate data, more complete data, more diverse data. Do we have data from all the regions and places that we need data to help us make more accurate projections? Utility. We want to launch a platform for bi-directional knowledge transfer between science and society. It's not helpful if we create science in a university setting and we don't get it into the hands of people who need it, people who can do their own analysis specific to their needs and questions, and also sharing what we're already learning in terms of knowledge production on the university side. How do we share that knowledge in a way that's useful to the general public? And also, how do we expand the reach? So we have this philosophy that in order to strengthen our ability to do all of this, we also have to strengthen who's doing this work. We have to strengthen the pipeline of the people who are trained as climate data scientists to improve the science itself. Those diverse perspectives and backgrounds coming into this work is really, really critical, and a huge problem in all of the disciplines involved in LEAP right now. We have a big representation issue that we're also trying to resolve as best we can. And what's novel about LEAP is really thinking about how we leverage and advance data science across the entire climate model pipeline. So it's not just clouds, it's not just oceans, it's not just air pollution, it's not just temperature. We're trying to understand each of those systems in more detailed ways and the ways that they relate to each other to help us improve predictions. And data science is giving us some basis for how to manage that much data and how to process and model that much data in a way that's useful and meaningful. So our vision, again, is thinking about these three components. And so my role, you might think, what does a social worker have to do with climate modeling? I think about this equity piece, right? I know we're not all going to be affected equally. I know there's an issue with translating science to and giving access to data and science and information more broadly. So these knowledge transfer components are really important. We describe this as bidirectional because we believe we don't hold the only knowledge that matters. Communities other stakeholders have knowledge that's important that we know and understand in order to do a good job at this. So we have to build communication pathways back and forth. We're not just handing over knowledge or professing to know and understand everything. We want to build an environment where we're able to learn from what people understand about their own lives and their own communities so that we can do better science. And we also have very significant educational efforts. So this is a long game. We aren't going to fix these problems in the shorter term. Again, how do we improve the pipeline of people who are able to engage in this work, and what can LEAP contribute to their preparation in education so that we change the face of people engaged in climate data science. So we wanted to try and keep it straightforward and start there. We're happy to take your questions, anything that wasn't clear, but also just your general thoughts about how we might go about doing this. What would make you get engaged with this kind of work? What are your concerns or questions about climate change at the global level or just in your neighborhood? So we're happy to jump in and answer any questions you have. And I'll stop sharing, but please let me know if you want me to go back to any of the slides. I'm happy to do that as well.
Thank you so much, Dr. Cogburn and Dr. Gentine. We will go back to question in a little bit, but I really want to thank you. And also it was great to hear the amazing work that you are all leading and the potential impact on predicting climate change. Also, I very much appreciate your dedication and commitment to integrating community needs and also being real advocates for climate justice in all of its forms. And so, yes, I'm inviting mentors and mentees to put your question in the chat. But then I also want to highlight the wonderful work that some of our mentors are doing. And so for that section, I'll pass the mic to my great colleague, Ebony. Do you want to introduce that section?
Yes, good evening, everyone. So we're happy to have several of our future science mentors with us this evening who work in the field of data, computer science, or technology. And we've asked them quickly to share the focus of their work with us. So we will start with Grace.
Oh my gosh, my throat was like, ooh. Hi everyone, my name is Grace. I'm a second year PhD student at Northwestern University in Material Science and Engineering, where I work on a range of medical devices that dissolve in the body. So they're environmentally sustainable and also can address healthcare challenges and avoid costly surgical explantation of devices. And beyond the lab, I'm deeply involved in studying the impacts of bias in technology. And so I'm working on both policy implications, levers, and all the way to researching new ways of engineering education so that we could teach engineers how they can engage critically and participatorily, making up the word on the spot, to design better tech. So that's sort of my range. This was a great talk, and yeah, passing the mic to the next person.
Thank you, Grace. Hassan?
Hi, everybody. My name's Hassan. I'm a fourth-year PhD student at Virginia Tech. I play a little bit of tug-of-war between biomechanical engineering and cerebral palsy therapeutics. So where my research falls is I look into balance, posture, and locomotion for children with hemiplegic cerebral palsy, where half of their body is impacted and slightly paralyzed. So a lot of my work is getting them into our motion capture lab where we have force plate technology, and we want to create as in-depth a picture and some context towards how do they walk, how do they stand, what's the effect that walking has on their standing balance, and do they prepare themselves differently if they know they're going to be walking, for instance. So a great part of my work is that luckily nobody has really asked these questions before when it comes to children with cerebral palsy. So a lot of my work when it comes to social justice is working as an advocate now for students and for other younger kids who are out there who won't be able to speak for themselves. So a lot of my work is trying my best to inform clinicians and inform other research scientists of the best ways we can help these kids in the future, which is really great and rewarding.
Thank you, Hassan. Caitlin?
Good evening, everyone. My name is Caitlin, and I'm a first-year master's student at Duke University, where I am studying biostatistics. So biostatistics is a field which utilizes mathematical concepts and also data science to solve biological questions. And my research specifically involves using machine learning to predict the mortality of end-stage renal disease patients here at the Duke University Hospital using electronic health records or EHR data. So EHR data is basically all the data the hospital collects on the patient during a hospital visit, which includes demographic data, medical data, and insurance claims data. So creating these predictive models can help assess how different risk factors such as race, education, and socioeconomic level can impact a patient's survival. But also, Black or African Americans are more than 3 times as likely to have kidney failure compared to white Americans. So these models can also help demonstrate the large gap in health care quality and its fatal impact on racial and ethnic minority groups who are often disproportionately affected in the healthcare system.
Thank you, Caitlin. Prue?
Thank you, Ebony, and thank you for the wonderful talk. Hi, everyone. My name is Puru. I recently started working full-time for an analytics / software company, and what we do is provide solutions, analytical and database solutions to companies in the pharmaceutical domain. And what some of the projects that we'll be involved in going forward is, so our scope is quite expansive in the sense that we look at companies and institutions who are dealing with, data-based questions and concerns, from the sales aspect to the drug development aspect to the drug delivery. And I think we have a very, very big scope and a lot of potential in terms of answering those questions. And if companies can help, get some assistance using our analytical solutions, that is also going to affect the public and, the policy and, other governmental institutions. One of the things that as we became familiar with during COVID was how disproportionately African-American and some low-income communities were not having access to medical facilities or even the vaccines. You have data, then you can answer so many, you can really dig deep, using programming languages and visualization softwares, like a simple graph that 10 years before, 10 years ago was not available, would be available. And that one graph alone could tell you which communities are not getting equal access. So that's some of the questions, that I hope I get to answer. And I'm really passionate about sustainability as well. So thank you for the great talk again.
Thank you, Prue. And last, we'll have Elaine.
Hi, I'm Elaine. I'm a first-year PhD student at Duke University studying chemistry, and I recently just affiliated in a computer science lab where we use and improve protein design algorithms and softwares to solve the protein design problem, which is basically how do we design a protein with exceptional folding and flexibility that would allow it to perform a desired function in a biological environment. And these designs are mostly to be used in drug development for viral and microbial infections.
Thank you, Elaine. Thank you to all of our mentors and scholars. We encourage you to watch all of the mentor tours available on our YouTube channel, and we will drop the link to the playlist in the chat. And now I will turn the mic over to my colleague, Dr. Sheets, who will lead the Q&A.
All right. Thank you. The talk was amazing, and it was great hearing the work that our mentors are doing as well. And so we received a lot of questions via the chat and private message. So I want to start with Dorianis. And Dorianis, I can read your question or you can read it. Just let me know what you prefer.
It's more so a comment than a question. Yeah.
Okay. So I'll just read it. One of the problems with addressing the error in global climate models is that we are heavily constrained by computational resources. And so the more accurate, i.e. resolving higher resolutions and inclusion of microphysical processes, we want our models to be, the more computationally expensive these models are to run. And so this is an issue that Dorianis runs into often working at a national lab. And she just wanted to comment that that was a really big issue.
Maybe I can comment on that. I think you're completely right. There's also the emission part of that. I mean, the more expensive those simulations are, the more emissions we are actually making. It's actually funny. There are like quite a few numbers about like those what we call SIMIP, this intercomparison of model and how much emission we have, and it's not small, right? I mean, because those big experiments do need quite a bit of compute hours. I would say to that, I mean, I agree with you, and there's the higher the resolution, the better. It's like a video game, you could say, but there's always a limit, so even if you were at a tiny scale, I mean, you cannot really resolve droplets, you cannot really resolve the ice crystals, you cannot really resolve the microbes, so there's always something that you will need to be representing in some sort of empirical way. And the unfortunate thing is that even then, I mean, they have a huge impact, so again, if you think about clouds, the droplets or the ice crystals are really important. And so sometimes the resolution is not just the end or the solution, right? So even with a much more pixelized model, you could actually do a very good job, so maybe that's also, I don't know, maybe some sort of humility towards resolution, I would say.
Thank you. Dorianis, do you have anything further you want to ask or say? So we have a comment from one of the mentees, Labake. It says, from my understanding, industrialization and carbon emissions are directly related. So what about developing countries that are in the process of transitioning? And what's the solution for them to be industrialized while also being environmentally conscious? And I'll put that in the chat for everybody.
I mean, I don't know, I can answer maybe part of that and feel free to jump in. I mean, that's always been my feeling. And I used to live in North Africa, and it's easy to say, once you're developed, okay, why don't you guys follow? And, but people, I mean, of course you would want, I mean, those countries would want to develop, I think the main point to that would be, if you have an alternative to the system that we have and to the model that we have, that's so there's one example now, like Puerto Rico, for instance. They were hit by a big hurricane, and they were stepping back, and they said, can we do something about our electric system? Can we have renewables, smart grids? Can we just not do the same bad thing in a sense, And sometimes this stepping back might be actually a very useful thing in the long run. So there are opportunities where, for instance, in many places, going through to solar might be a good strategy. And we might not need to follow some of the bad examples that we had in the developed world or developed countries. So I think there's a lot of opportunities there. And sometimes it can be much cheaper, also in the long run, So I think that's an important discussion of not just following some bad examples, but really like trying to think fresh, and that's a good opportunity for many places, There's another really good example. So for instance, in many parts of Africa, there was no line phones for a while, and people transition right away to cell phones, right? So potentially there are many places where you can go right away to like a lot of renewables. So why do you need to go and have an obsolete system as opposed to having things that are much better right away, right? So I think there's a lot to be learned, like backward, like from developing countries back into the so-called developed countries.
Right, and if they have, that's a matter of having the right resources and support for implementing those things, but sometimes being able to skip that step is easier, right? So in places, in older cities, for instance, you're retrofitting really old systems that are much harder to change than a place that didn't have the system to begin with, and so you can start anew. But I don't know the global circumstances around this, Pierre, but that sounds great. And then are there really the resources to do that, right? If we were really taking a global, transformative approach to this, right, we might even think about some of these cities as more of a blank slate, right, in terms of these systems, and think about experimental designs for reimagining eco-friendly cities, for instance. I don't have a sense of how often that's actually happening.
There are some actually great examples of which in Alabama and Louisiana. So we don't need to go to a different, but where you have very underprivileged communities, and they are starting fresh, and they are saying, can we have a small scale community system for energy, for water? And it's actually way cheaper. It's more resilient to shocks, and the impact. And sometimes like we are being pushed to that model, but if you think in a different way, you can have a much better system, more resilient and better for your community.
All right, thank you. Labake, I saw your hand up. Would you like to comment?
No, I was gonna ask like another question, but then they kind of answered it.
Oh, perfect. Awesome. So now we have a comment about the actual communities that you're working in. And so how is Columbia University actually engaging in the local communities such as Harlem in your work? Like, what, do you have a community advisory board, or is that something you want to do in the future? Can you share more?
Yeah, we're still getting up and running and trying to sort of build the basics of the center, but we're doing a couple of things. So one, we want to have different stakeholder relationships. So we want people in the corporate sector, we want people in education, we want people doing climate justice work in our surrounding communities, right? So organizations like We Act, for instance. So we want to build those relationships and have started doing that. And then we're still trying to figure out what's the most meaningful way to create conversation, right? We could easily say, we're hosting a talk series and it's open to the public and people can come hear us go on and on about the science that we're doing, which is one piece of it. And another piece is, how do we actually build relationships that allow for meaningful exchange of ideas and conversation and co-learning, which takes more time to build. And frankly, when you're coming from an institution like Columbia, you're dealing with the reputation of that institution in those communities. It takes more work to convince them that we aren't just extracting information and using those communities. So it will take more time with certain stakeholders than it will with others, but it's hugely important to us. I would love for us to talk about this evening even, right? What are some good ways for us to start doing that and thinking about that? When I think about an advisory board, often those take on this symbolic role as part of, in science communities, and that's not something we want to replicate. I work in the studio is called the Justice and Equitable Tech Studio, and our community consultancy are like youth from Harlem who we pay to tell us when we're messing up, or just giving us their brilliance and thoughts, right? But they have power to change what we do. And so I definitely want to build that type of environment, but recognizing that we have some historical barriers in the way of that, and it's going to take a bit of time.
Yeah, I think you hit some really good points there, especially the fact that, when working with communities, it takes time. And so I feel that people that aren't used to engaging with communities, they want to kind of speed through and think that, they're going to have the answers to what they need like overnight, when it could take, years to really develop relationships with the community, just given reputations and of universities and that type of thing. And then just like you mentioned, just those historical barriers that are in the way.
Yeah.
I think that you answered this next question just a moment ago, but you can expound if you feel like you need to.
Yeah.
So how can issues of social justice and equity be considered in the development of new technologies? So.
Not can be, have to be. That we, I'm a social worker, right? I am built to center the people who are going to be most gravely affected by what we do. I think of them first. And I think we have to do the same thing with technologies, right? We can't design or create tech solutions that have this sort of ambiguous, middle income, wealthy white user in mind. That's not often conscious. We don't say that, but that's who we tend to create iPhones for, right? And so we have to think about the people who are not going to have access or be most gravely impacted by those technologies and consider what's going to happen to them, to consider what their needs are. And I think this sort of tech for good movement really needs to shift to some understanding. It's not what is for good and who's best positioned to help us understand how to conceptualize that and then actually implement that, right? And it's not a computer science engineer, right? So you have to change who's sitting at the table and having these conversations. We can't click our heels and just have like best intentions in mind and hope that we have positive impact. We need different voices at the table to help us achieve these goals, even articulate what they are. What does justice mean? If you're going to achieve justice, you have to understand what injustice is and what injustice has been. How do you repair, not just avoid future harms, right? So equity is one thing that's more present focused. Ethics helps us think about how do we avoid future harms. Justice thinks about repairing past harms. And creating technology for that purpose is really different than saying, okay, from here on out, we're going to try not to hurt people. But you've been harming people for multiple generations. What do you do about that? And so you don't get that by just hoping that you don't do bad and simply wishing that you or intending to do good. You have to change who's at the table with you at every stage of development, from conception to implementation, when we're creating and applying these technologies.
Yeah, because I totally agree. Like having, diverse people at the table, but then also making it such that they can communicate or translate these messages to their respective communities. Because, when we started, Dr. Gentine spoke about like, you have to understand like these terms and what they mean. And so when you go into these different communities, they may not know the terms, or they may have misunderstanding of, of what they are. Or they may call them something else, and so part of it is like trying to like figure out like what those are to what those things mean to your community as well.
And just to quickly add, Jolana, you also don't need to be a programmer or a computer scientist to have something meaningful to say about tech, right? You don't have to understand the nitty gritty of a technology to have some thoughts about facial surveillance, right? And so there's some basic pieces that people need to understand. And then once they have that, listen to what they have to say, right? They don't need to become experts in the space. And the same applies to climate, right? People know how their lives are being affected by temperature change and flooding, et cetera. They don't have to understand what climate modeling is or how we do that. We think there's value in that, in people understanding that, but that's not the threshold that we're shooting for in terms of being able to learn from people about what needs to happen next, or where the harms might occur if we get this wrong. The bar for what you need to understand is actually very different than being a coder or being a climate scientist.
Those are all excellent.
Yeah. I apologize if it has been misinterpreted, but my intent was more that to kind of say that the politicians are putting kind of a low bar, in the sense that they say, okay, they want to reduce the emissions, but really, what we want to do is go negative, right? And that's an easy way for them. That's an easier sell, right? So it's not to criticize anyone in this room, and and especially not in communities. But I think it's a mechanism that people use. They talk about something else, like the target is not the right one, right? They talk about, is the rate going a little bit lower? No, we need to go negative. That's a different game, right? So anyways, yeah.
And we believe like people can understand complex scientific concepts if you explain it clearly, right? It's your job to figure out how to explain it. So how do I explain the difference between methane and CO2? I understand that now because we had a clear conversation about it right this afternoon. So we also shouldn't underestimate communities and their ability to digest and understand complex concepts.
I totally agree. There's in the comments.
So we have time for one more question.
Gosh, there's so many.
Yeah, which is great. But we have time for one more question, and Gianna, you're gonna have the hard job to choose.
Hey, let's see. Well, this is kind of like a suggestion I think may feed into some of the community work. So this person has, they say, I think trying to interact with high schools might help. They'd be working with educators, students, and administrators, which would kind of trickle over to their families and their message could spread from there. From this person's experience, they found that as they move through high school, they started having more influence over their family than they have over this person because of what they've been learning. And so I thought that was like a good comment.
Yeah, I just put a link in the chat. We don't have time to go over it, but we have a substantial educational component that's rooted in equity and community relationships. We agree. We think that's a critical place to start at all parts of the pipeline. And so I shared the link just in case anyone's interested in seeing the many things that are being led by one of our other leaders of the project, Tian Zhang, who's leading this effort.
Yeah, thank you. And we'll send out that link to everyone as well, just to make sure that they have it. And I will definitely send you these questions via email. But this has been wonderful, and we do thank you. And so I'll pass it over to Garance, who's going to close us out.
Yes, and also like before, we have 4 minutes. So Pierre, Dr. Gentine and Dr. Cogburn, do you have any final comment that you want to share? And do you each want to take 1 minute? You don't have to, it's not mandatory. Final comments that you have and message that you have, like for our graduate students, but also for our high school students that are like attending today.
Like a quick one, would be, and that's very much what we discussed with Courtney, is that, it can oftentimes feel like gloom and doom, like doom time, right? So, but I think there's a lot of, especially for people in STEM, there's a lot of opportunities to actually be the source of change, right? So how do we change a lot of that? Like, and I think hopefully we alluded to some of that, like in terms of the data, in terms of the adaptation, and hopefully the game changer also on mitigation. Can you remove that stuff from the air, So I think there's a lot of opportunities and very interesting for humanity and for society.
Yeah. I agree. And I think a lot of people in this space are thinking about the kinds of changes that are coming to us as a result of climate change. If we use it properly, will give us a chance to reset and think about equity in society in a different way and clear the slate, right? Clear the tablet in some ways to help us rebuild and transform. And I think that's a nice way to think about it too.
Thank you. I so appreciate how you're putting equity to the forefront, understanding that it's a process, understanding that there is no silver bullet, but also being willing to ask the questions, right? And explore all the ways in which you can really integrate and include community in the work that you're doing. So thank you for this. And we're thankful to have a younger generation who is interested in combining science with social justice. And that's the core of, of this project. So I want to thank all of you for attending this community talk. Thank you, Dr. Cogburn. Thank you, Pierre Gentine. I invite you all to visit our website at ourfutureisscience.org and follow us on social media to learn more about our initiative, our future events, and our educational campaign. And mentees, don't log off yet. We have 15 minutes devoted to you for you to ask us like any question, okay? So it can be about your capstone project, this community event, or additional topic. But now, again, thank you. And anyone who is not a mentee is welcome to to leave.
Thank you. Bye, everyone.
Thank you.